Hi everyone, Queeveen here from the comfort of my kitchen. In today's video, we are going to take a quick look at how you can figure out where you are and the limitations to figuring out where you are using the sky. So of course, we're mostly going to be looking at the nighttime sky, so we will move into nighttime. This is our view as we would expect. We can find north pretty easily from here in the northern hemisphere by looking around for the plough or the Big Dipper. If you are high enough on the northern hemisphere, then the plough or the Big Dipper will always be visible. It will be circumpolar, but below a certain latitude, the plough will be under the horizon for at least part of the night, at least sometimes of the year. Thankfully, there are other constellations like Cassiopeia up here that can be used to find the North Star. Now, of course, if you are seeing the sky like this with all of this light pollution, there's a good chance that you are at least not far from civilization, so finding your way shouldn't be too difficult. You'd likely be able to find roads or signs or street signs or something if the sky looks like this. So we will head out to the countryside. Just to be a little bit more realistic, if you're truly lost, the sky might not be absolutely perfect, but we will give it a little bit less light pollution just to show the sky a little bit more full, as it were. So we found the North Star. One way that we can figure out where we are is by looking at the distance from the North Star to the horizon, or really the angle between the North Star and the horizon. We've got a little angle measurement tool here that we can use in Stellarium. In real life, a sextant and similar devices are what you would use to figure out this kind of thing. So we'll try to click exactly on the North Star. Maybe not exactly. We're going to be a little bit off, but that's okay. And we'll drag down here to the horizon as straight a line as we can, hopefully all the way to the horizon. So here we're certainly going to be a little bit off. I can see that already. I might be able to fix this a little bit. We'll zoom in and try to be a little bit more exact, although it is tricky with the just using the cursor here. Okay, that's probably a little bit closer. So this is showing us 52 degrees, 3 minutes and 32.36 seconds of arc. This is how the 360 degree circle is broken up into degrees, minutes and seconds of arc. Down here in the bottom, it's showing our location as Cork in Ireland, and showing our exact location at 51.898 degrees north and west 8 degrees. So as I said, we're off. We're off by a couple of minutes here, a couple of minutes of arc. But it is, of course, partly due to the horizon being a little bit obscure, a little bit hard to see exactly, and of course the North Star. I haven't lined up exactly on the North Star here. If you were measuring this with a sextant of some sort, then you would be able to, most sextants have a little telescope, a little range finder or sight on them that allows you to be a bit more accurate. It allows you to see exactly what star you want to take a look at. So hopefully I'll be able to extend this down here. The horizon at this level of magnitude should look pretty flat if I am straight down underneath it. So that is lined up, I think, a little bit better. And if we come back up, of course, it still is a little bit off. So without the proper tools, this kind of reckoning of your latitude can be a little bit tricky. But this works from everywhere. One drawback of Stellarium is that I can't send myself to a random location without it essentially telling me where I've gone. But if we go to a different location that's not too far away, we'll go down here to somewhere in Spain. We can see here that we've gotten the North Star closer to the horizon, and this is because we are closer to the equator. You might also notice that the plough or the Big Dipper, much harder to spot here. We are seeing some of it, but a lot of it is now under the horizon. We still have Cassiopeia up there, roughly pointing us in the correct direction, and these two constellations are pretty much on opposite sides of the sky to each other. So either they will both be on the horizon, or one will be above the horizon and one will be below. Of course, unless you're in the southern hemisphere. But we've now traveled to a different latitude, so let's zoom in here, and yet again we will try to be as accurate as possible. Yep, here we are, clicked on the North Star on Polaris, and we'll come all the way down to the horizon and try to get these things lined up Just exactly right. Of course, it is dark and the landscape is dark. So finding the exact horizon with all of the blur and atmospheric distortion is a little bit tricky. But there we go. It's telling me 38 degrees, 18 minutes and 11.74 seconds. And again, a little bit off. We're down here at 37.7467 degrees north. So we are a little bit off yet again by almost a degree here. But that is due to really my own limitations, not being able to draw the line in exactly the right place. And we can see here we're after traveling a reasonable distance around the Earth as well. Our longitude is also quite different here. It's now at 3 degrees west rather than about 8 degrees west. Again, we could travel to various other locations. If we go down much closer to the equator, we'll come down to about here. Then we'll still see the North Star above the horizon. Now, at this time of the night, at this time of the year, the plough is completely hidden under the horizon, but we still have Cassiopeia up here, helping us to see roughly where we should be looking. So we'll take a closer look at Polaris again, and we will drag this line down to the horizon, which shouldn't be this far. It feels like I should be a little bit closer to the horizon. Here we go. It's somewhere around here. Wow, where exactly the true horizon lies is a little bit, it seems a little bit blurry to me, but that gives us 19 degrees 6 minutes. And if we take a look down here, 18.5 degrees. So again, we're off by about a degree, and again, that's on me. With a proper sextant, with a proper measurement of where the horizon is, with a level, something to balance you, then of course you'd have a much better idea. And this kind of navigation was much more important out on the sea, where of course the horizon isn't obscured by things like trees and buildings. It can be a little bit easier to see, especially on a clear night. So that is, of course, the North Star is able to tell us where north is, and from there we can figure out turning the whole way around will point us south and roughly down in this direction. Yeah, thankfully Saturn's in the sky, and I know that when Saturn's at its highest, it's going to be above the south. Saturn will be at its highest a bit before midnight, so there is a good chance that we're looking pretty much south here. That's the kind of thing that, of course, you need to be looking at the night sky regularly to build up that kind of familiarity, to know where Saturn is on a given night and know that it won't have moved too much since the last time that you saw it. But this measurement of latitude isn't too hard to do. It works in the southern hemisphere as well. Of course, you have to look for a different part of the sky. We've also moved far enough around the Earth that we are now looking at daytime once again. So here we are. Looking north, I believe. So we're seeing objects and constellations like Taurus, the Pleiades, Orion, things that we'd normally see in our southern sky, and Saturn as well. We're now seeing around the northern sky. But we want to look south here because we're looking for the Southern Cross. So here we go. Down here is the Southern Cross. And the Southern Cross, unlike the North Star or the Pole Star, the Southern Cross doesn't actually rest directly above the South Pole. It more points at the South Pole. So if we follow along this line, it's somewhere around here. It does seem to be a reasonably empty patch of the sky, but it's where the long arm of the Southern Cross will point. So it should be somewhere around here. If we move through time, yeah, we should see, it appears as if the stars are rotating around this point. Roughly, I'm not exactly in the right place. Of course, that's a common issue for me, but it's roughly pointing in the right direction. Of course, here in Stellarium, we have grids that can help us. Yeah, just there is our South Pole, the pole of the sky. But we can again do the same thing. Now, of course, looking down here on the toolbar, I already know how many degrees latitude we have, but by following the Southern Cross up into this empty space and drawing a straight line down to the horizon, we shouldn't be too far off. We're a lot further off than we were in the northern hemisphere. Of course, that's because there isn't really a North Star to click on. I can't be quite as accurate. We're seeing 42 degrees. This is saying 39 degrees, so we're off by about 3 degrees. That's possibly because, yeah, I clicked a little bit too high. So we need to follow across a bit more directly to here. and drag down to the horizon. There we go, 38.5, 38.5-ish, when really it's 39. That's, again, off by about a degree. So imperfect, but that is the principle of being able to tell at least your latitude just using the night sky. Of course, if you're out during the day, how high in the sky the sun is during the day is going to vary significantly with the time of year as well as your location. So measuring the angle of the sun in the sky can't tell you your latitude. However, you can use the sun to figure out where south is by figuring out when shadows are at their shortest. If you have a stick or a pole and you measure the shadow so that you can see when the sun has reached its peak, the shadow will be directly opposite the south. So you can use the sun to figure out where south is, but you can't use it to figure out your latitude the way you can use the North Star to figure out your latitude. Longitude is a whole different and much more complicated problem. It almost always needs a watch or a clock or a chronometer in order for you to measure it, but that is something we'll have to get into another time. So thank you very much for watching. I hope you enjoyed this video. If you did, please do like it, and if you like this kind of content, then please subscribe to this YouTube channel. You can also read this information on my website, queeveenscontent.ie. So thank you very much for watching, and hopefully I'll see you back here next time.